modulus of a complex number. Let z equal to a plus ib is a complex number. Then modulus of complex number z is denoted by modulus of z is defined as square root of a square plus b square. So this is the modulus of the complex number. For example, z equal to 3 plus 2i is a complex number, then modulus of z is square root of a square plus b square. Here a means 3, a plus bi. Complex number is of the form a plus bi. A is equal to 3, so 3 square plus a plus bi. B is equal to 2, so 2 square. So this is 9 plus 4. This is root 13. So therefore, modulus of z equal to root 13. So this is the definition of the modulus of complex number and how to find modulus of the complex number. Conjugate of a complex number. Let z equal to a plus ib is a complex number, then conjugate of z is denoted as conjugate of z and can be defined as, so z equal to a plus ib, conjugate of z is a minus ib. So this is conjugate of z. So for example, z equal to 2 minus 3i is a complex number, then conjugate of z is 2, so here minus is there, so change the sign. So a plus ib, z equal to a plus ib, then conjugate of z is a minus ib. Change the sign of imaginary part. A plus is there, so write minus. Here sign of imaginary part is minus, so change it as plus. So 2 plus 3i is the conjugate of the complex number 2 minus 3i. Multiplicative inverse of the complex number. So let z equal to 2 minus 3i is a complex number. So find the multiplicative inverse of the complex number z equal to 2 minus 3i. So multiplicative inverse of z is z inverse is equal to r1 by z. So z inverse r1 by z is the multiplicative inverse of the complex number z. So z equal to 2 minus 3i, 1 by z is 1 by 2 minus 3i. So here 1 by 2 minus 3i, so this is 2 minus 3i multiply by 2 plus 3i in the numerator and denominator. Here 2 minus 3i is there, so multiply and divide by 2 plus 3i in the numerator and denominator. So we get 1 into 2 plus 3i, 2 plus 3i by, so this is of the form here a minus b into a plus b. So therefore a minus b into a plus b is a square minus b square. Here a is 2, 2 square is 4, a square minus b square. B means 3i, 3i whole square. 2 plus 3i by 4 minus, so 3 square is 9, I square is minus 1. 2 plus 3i by 4 minus into minus plus 9 into 1, 9. So 4 plus 9. 2 plus 3i by 13. So therefore, the multiplicative inverse of z equal to 2 minus 3i is 2 plus 3i by 13. This can be also written as 2 by 13 plus I into 3 by 13. 2 by 13 plus I into 3 by 13, which is the multiplicative inverse of the given complex number 2 minus 3i. Next problem, find the multiplicative inverse of z equal to root 5 plus 3i. So multiplicative inverse of z is z inverse or 1 by z. Z inverse is equal to 1 by z. So 1 by z is root 5 plus 3i. So 1 by root 5 plus 3i into, in the denominator root 5 plus 3i, so multiply by root 5 minus 3i. Here sign is plus. So multiply by root 5 minus 3i in the numerator and denominator. So we get 1 into root 5 minus 3i, root 5 minus 3i. In the denominator a plus b into a minus b, that is a square minus b square. A is root 5. Root 5 whole square is 5 minus b square. B is 3i whole square. Root 5 minus 3i by 5 minus. So I square is minus 1. 3 square is 9. 3 square is 9. 9 into I square is minus 1. 9 into minus 1 minus 9 into minus plus 9. 5 plus 9. So root 5 minus 3i by 5 plus 9 is 40. So this is root 5 by 40 minus I into 3 by 40. So which is the multiplicative inverse of the given complex number root 5 plus 3i. So find the multiplicative inverse of the complex number z equal to 4 minus 3i. So multiplicative inverse is z inverse, that is equal to 1 by z. 1 by z is 4 minus 3i is equal to 1 by 4 minus 3i. So in the denominator 4 minus 3i, so multiply by 4 plus 3i in the numerator and denominator. So 4 plus 3i into 1, 4 plus 3i divided by, in the denominator a minus b into a plus b, a square minus b square. A is 4 square minus b is 3i whole square. So 4 plus 3i by 4 square is 16 minus 3 square is 9, I square is 3 square is 9, I square is minus 1. 4 plus 3i by 16 minus, so minus 9 into minus 1. So minus into minus plus, so 9. So 4, denominator is 16 plus 9, 25. So 4 by 25 plus I into 3 by 25. So which is the multiplicative inverse of 4 minus 3i. The multiplicative inverse of z equal to minus I. So the multiplicative inverse of z is z inverse, that is 1 by z equal to 1 by z is minus I. So 1 by minus I. So in the denominator I is there. So multiply and divide by I. Multiply and divide by I. So this is I into 1 is I in the numerator. In the denominator I into I square. So minus I into I is I square. So I divided by minus of I square is minus 1. The value of I square is minus 1. So I divided by minus into minus plus 1. I by 1. So this is I by 1 is I. So therefore the multiplicative inverse of the complex number minus I is I.